All right, let's continue with 2.5. Since we talked so much today, when are we out of here? Quarter of, right? Okay, so I don't know if we'll finish today or not, but I will give it a good shot. Let's see, last thing we did was 3 by 3 determinant, right? So I'm not going to go through that right now. What we're going to talk about is, before we talk about this multiplicative inverse thing, let's just talk about what an identity matrix is. Identity matrix. And we're going to talk about it for multiplication. For multiplication. Let's go back and not talk about a matrix. Let's talk about a regular number. What's the identity property for multiplication? It is this. Like if I take a number, what do I multiply it by in order to get the number that we started with? It's just 1. It's as easy as that, okay? So the identity property for multiplication is if you multiply a number by 1, you get the same thing that you started with. All right? So we want to find the identity matrix for multiplication. What's it going to look like? What's the matrix look like if I multiply it by another matrix? I'm going to end up with the original matrix. All right, for instance, what if I go A1, A2? We'll just do a little 2 by 2 matrix, B1, B2. I'll just show you how it works. I'm not going to show you like how they came up with it, but I'll show you what actually works. So here's what I want to end up with. Okay, so here's big blank right here. What do I need to multiply this by, this first matrix, in order to end up with the same thing that I started with? Make sense? Right? This matrix and this matrix, the same thing. What matrix do I want to multiply it by? Now you might say, well, just multiply it by a 1. Well, that's not really a matrix. I want to multiply it by another 2 by 2 matrix. And then when I multiply those together, I'm going to get this for an answer. What's like a guess? All right, my guess, I'll tell you, if I didn't know this, my guess might be putting all 1s in there. Kind of makes sense, right? Multiplying by a 1. Let's just see if it works. What if I put 1, 1, 1, 1? Remember how you multiply them together? Right? You multiply across this way and down this way. Remember that? All right, so what would we get? We get A1 what? Then we add, don't we? Plus what? Plus B1. So is this an A1 plus a B1? No. Right. So right now, you know that's not going to work. So we can't do that. But I just want to be left with an A1. So if I multiply A1 times 1, that's an A1. What would I have to multiply B1 by in order to be just left with an A1? A 0, right. So let's make this a 0. Okay, and just for the sake of time, I'll just show you what it is so you get the idea. So let's see if that works. Everybody watching? Again, let's do that matrix multiplication. A1 times 1 is A1 plus B1 times 0 is 0, so I'm just left with what? A1. With me? All right, so, and then we do what? So we go this way and that way. That's what we should have done. Okay, so watch. A1 times 1 is A1, and then plus B1 times this 0 is 0. So I've got an A1. Now I do what? This times this one right here. So I go A1 times 0, which is 0, and then what? B1 times 1 is B. So that does work, doesn't it? Then we do the same thing with the bottom. A2 times 1 is A2, plus B2 times 0 is 0. That's an A2. Then the last one, A2 times 0 is 0, plus B2 times 1 is B2. So that does work, all right? So what's our identity matrix? Our identity matrix is this right here. So this is our identity matrix. There are times where we need to know what the identity matrix is. All right, enough of that. I spent too much time on that already. What we're really wanting to do today is find the inverse matrix, okay? That's the key to what we're going to do today. All right, so let's write that down. So this is something that you may want to write down, okay? Because this can get a little bit complicated. I don't think you're just going to be able to sit here and look at it and say, oh yeah, okay, I think I can figure that out. Let's first of all talk about what an inverse is. Kind of like what we did with the identity matrix, right? We said 3 times 1 is 3. That's an identity. What does it mean to be an inverse matrix of multiplication? Okay, or a multiplicative, I like that word, multiplicative inverse. What does that mean? Well, watch. If I had 5x equals, 15. Super basic algebra equation. How would I get x by itself? What would I do here? Divide it by 5, okay? Let's say we didn't want to divide it by 5. We want to multiply it by something. I could still do that, couldn't I? What would I multiply this by in order to get rid of the 5? A 1/5. Everybody see that? So what did I do? I multiplied by the reciprocal. Remember that? That's what division is. Dividing is the same thing as multiplying by the reciprocal. So if I multiply this side by the reciprocal, I come over here and I multiply that side by the reciprocal. You with me on this? Okay. Is everybody paying attention? I don't think so. I like 3 or 4 of you, your eyes aren't even up here. You got to watch this, okay? Because you're not going to be able to follow if you don't watch what I do. So, and then we can do the rest. I don't really care about the rest of it. What I care about is multiplying by the reciprocal. That's the same thing as dividing. So if I want to get x by itself, how do I get rid of the thing that's being multiplied by it? I multiply by the reciprocal. You with me? So if I had something like this, what if I had 2/3 x equals, 12, okay? How would I get rid of that 2/3? I'd multiply by the what? Reciprocal. Remember this? Yeah, we just did it, all right? Everybody with me on that? So again, I'm going to try to beat this into your head, figuratively. How do I get rid of something that's being multiplied by my variable? I multiply it by its reciprocal. That's what the inverse matrix of multiplication is. That's what the multiplicative inverse of a matrix is. It's multiplying by the reciprocal or the inverse, okay? That word inverse kind of means reciprocal. We good so far? Any questions? All right. So let's now do a matrix. So now we kind of have a basic understanding of what a multiplicative inverse is. What we're going to do is figure out how do you find the multiplicative inverse of a matrix. Well, let's start with, this is matrix A. And again, we've done this before, A1, A2, B1, B2. We'll start with a little 2x2 matrix and find the inverse matrix of it. Here's what we do. I'm really not going to give you a lot of explanation on why it is what it is, because to tell you the truth, I don't think I really know, all right? But this is how you do it, all right? Everybody watching? So if I want to find, I shouldn't put equals. If I want to find the multiplicative inverse of this matrix, put a little arrow. So I don't want to put an equals because an inverse is not equal, right? 1/5 is not equal to 5/1. Agreed? All right. So I'm going to find the multiplicative inverse. Here's what we do. By the way, watch this. I just want to show you our notation, why I wrote the notation as I did. Do you remember doing negative inverses? We did that already this year, didn't we? Did we do stuff with negative inverses or negative reciprocal? What am I trying to say? Negative exponents. That's what I'm trying to say. We didn't do negative exponents? In one of my classes, I think Algebra 2, we did negative exponents. But anyway, 5 to the negative second, or man, if I could talk right today. 5 to the negative what? First. How could I write 5 to the negative first? That's the same thing as 1/5. Remember doing that last year? Watch, if I had like x to the negative second, how can I rewrite x to the negative second? I take it and I flip it to the bottom. Do you remember that?
Yes.
Yeah. And then I put a 1 over here Okay? So when you have something to the negative first, anything to the negative first is just the inverse of it. All right? It's the same thing as 1 over x. Do you see that? So when I see something to the negative first power, it just means the inverse of it, the reciprocal of it. All right? That's what it means. Even if I had like 2/3 to the negative first, what does that mean, 2/3 to the negative first? That means I'm finding the what? The reciprocal of this. What's the reciprocal of 2/3? It's 3 over 2. Okay? So when I write something to the negative first power, it means to take the reciprocal or multiplicative inverse, right? Just using those words kind of interchangeably. So the multiplicative inverse, if this is a, what do I want to find? I want to find a to the negative first. And that's the way you're going to see it. You're going to see find a to the negative first. That means it's the multiplicative inverse of this. All right? So I'm not just going to put 1 over this. But I am kind of going to, the beginning of it is kind of like 1 over this. So watch very carefully. There's basically 2 steps, 2 major steps that you need to do. The first step is we're going to write 1 over, right, because that's multiplicative inverse. And we're going to put this matrix, but we're going to make it a determinant, right? We just talked about that in the first part of this section. And then so I just write whatever those elements are. So that's A1, B1, A2, B2. So that's half of what we have to do, all right? Not that big of a deal. Put 1 over. How can you remember 1 over? Well, because we're doing the inverse, right? And the inverse is always 1 over something, all right? So that's kind of easy to remember, right? But we take the determinant. There's a big difference between just the matrix and doing the determinant. Remember that? Multiply diagonal, then you subtract, multiply those diagonal. All right. Then we're going to multiply it by, now this is something that 100 years I would give you, and you probably wouldn't figure this one out, okay? I don't know, maybe 100 years you might, all right? Here's what we're going to do. We're going to take this matrix, but we're going to switch a few things around. See these 2 diagonally? What we're going to do is we're going to switch places with those 2 things. Yeah, we did this last year, didn't we? Yeah, that's right. Now it's coming back to me. But anyway, I'm not assuming that you remember all of this, so we're going to start teaching from scratch. So we switch the order of this. So that means that's going to be a B2, and what's going to be down here? An A1. So I just switched, right? Put little arrows there. And then with these 2 right here, we just change the signs of them. We keep the B1 where it is, we keep the A2 where it is, but I'm going to change the sign. So I'll put a negative in front of it. Now that doesn't mean that number is always negative, because if the B1 was a negative, now it's going to be what? A positive, because I'm just changing the sign. Same thing with this. So we switch 2 things. Right here, we just switch the order that those 2 things are in. Right here, we switch the signs of those 2 things. And that right there is how you find the inverse of a matrix. All right, so I'm going to ask you one problem. Now, there's going to be other problems where this is just going to be part of what you have to do. This is only just one little part of what you have to do. But you need to know how to find the inverse of a matrix. And this right here, the multiplicative inverse of a matrix. And that's how you do it. Let's put some real numbers in here and see how it works, okay? Because we still got some work to do, don't we? Like if these were actual numbers, right, what would we have to do? Find the determinant. Multiply those together, multiply these together, subtract them, put 1 over whatever that number is. Then we're going to take that number and multiply it by all 4 of the things in here, okay? So we do have a little bit of work to do. So let's do an example. Let me find it. This is example 3 in the book, if you want to follow the book. All right, and they say find the inverse matrix. I'm going to put a to the negative first, all right? If a is equal to 2, negative 3, 4, 4. All right, so here's the matrix that they give you. What we want to do is find the multiplicative inverse. And this right here, put that in a box. That right there is how you find the multiplicative inverse. Am I going too fast or are you good? You keeping up? All right. I'll take your word for it. So what do we do first? I kind of put it out of the way. I probably should scooch it down so you can see it at first. There we go. Yeah, do the 1 over the determinant first, okay? So I'm going to put a to the negative first equals, remember, what does that mean, a to the negative first? That means find the inverse of matrix A. That's what that means. All right, so I put 1 over a determinant of that matrix, right? I don't change anything. I just put 2, negative 3, 4, 4. And we'll work that out. You'll get some number, all right? It'll just be a number, and then it's 1 over whatever that number is. Then we're going to multiply it by this matrix. Now, we got to do a little switching around, okay? I think last year I said we do the switcheroo, all right? So we switch two things. What do? I just change the order of those two. Instead of a 2 and a 4, what are we going to put? A 4 up here and a 2 down here. Now, what do we do with the signs? We change the signs. So this was negative, so now what is it going to be? Positive. This was positive, this is now going to be negative. Okay? So that's the new stuff. Now, from here on out is stuff we already learned how to do. All right? So that's the only thing new that we've done today. So I'll work up and down. Makes it a little bit easier to follow. So I'm going to put 1 over. Now, how do I find the determinant? Remember, those vertical lines specifically means we find the determinant. It's not just a matrix. We're actually doing something to that matrix. What do? 2 times 4 is 8. And then what do? Minus, right? What? Negative 12. And let's just figure that out before I multiply it by this. So what is 8 minus negative 12? 1 over 20, right? So that's 1 over 20, and what I need to do is take that 1 over 20 and multiply it by this matrix. That's just a scalar quantity, right? Remember we talked about that word scalar. It's just a regular number, and we just multiply everything inside that matrix by that number. So it's pretty easy now. What's 4 times 1 over 20 is just 4 over 20. And then this would be what? 3 over 20. This would be negative 4 over 20, and this would be 2 over 20. Okay? That's in a matrix, so I'll keep it in the matrix symbol. And then if you can reduce some things, go ahead and reduce them. 4 over 20 reduces to what? 1/5. 3 over 20 does not reduce, so I just keep it 3 over 20. This one is negative 1/5, and this is what? 1/10? And there you go. You just found the inverse matrix of that original matrix. That's your answer right there. Let me see. Yeah, is that all? Did I leave something out? Is that the last example? Seems like there was something. Yeah, I know I have that in my notes. I'm trying to, oh, there it is right there. It's right in front of my face. All right, I found it. Sorry, my mic came off. I don't think we will have time, so we'll do this tomorrow. That's all right. I gave you 2 days anyway. I gave you tomorrow to just work on the second part of the homework. So tomorrow, first thing we do, we won't take as much time as I did today at the beginning of class. But I'll just give you a sneak preview. Do you like sneak previews? You go to the movies and you got to sit through like half an hour of sneak previews, right? Yeah, I'll take it in a minute. Let me give you a sneak preview. So, watch. So this is solved by using matrix equations, it says. Matrix. I'm not going to start it. I'm just going to show you what we're going to do. Now, I talked about this the other day when we first started this lesson. I said this is one big reason why we learn how to do matrices is something like this. okay? So here's a system of equations, right? You could solve this. You've got now 4 ways. Well, after tomorrow, you'll have 4 ways to solve this. You could solve it by, what was the first way? Before that, by graphing, right? You could solve it by graphing. Then you could solve for it by substitution, or you could solve for it by elimination. Now, after tomorrow, we got a 4th way. What's another way we're going to be able to solve for it? Using matrices, that's right. And we're going to use that inverse matrix thing, all right? So that's going to come in handy when you do this, all right? So it's kind of cool. There may be times where using matrices might be a better way. At the very least, it's probably just as much work to use the matrix as it would to be substitution or elimination, depending on the problem. Like this one, I think the easiest way to do this is just by substitution, tell you the truth, okay? But we are gonna do it by matrix equation. So if you have that, what was that, 2-4? Section 2-4? 2-3, that's right, we skipped 2-4, right. So just leave it on this chair right here. Put it right side up. Make sure your first and last name's on it. Make sure section number says 2-3 on there.
I won't be Friday. I mean, I'll let you know. But
Friday.
I'm going to Liberty.
Oh, good. Well, that's a good reason not to be here.
I know, right?